Special right triangles are triangles that we use so frequently that we memorize the dimensions. We can use a scale factor to find the missing sides of special right triangles. In this special right triangle, we're asked to find x and y. This triangle is a 30, 60, 90 triangle, so we'll draw our 30, 60, 90 template. And I'm going to use A on it because I don't want to use letters that are in the problem. So I've got A root 3, and 2a. And I'm going to start with the side that I'm given. And I'm going to give, it gives us 5 equals a. So if 5 equals a, we can say that 2a is 10, and that 5 square root of 3 is a square root of 3. And sometimes I just make a little chart instead of putting it on the picture if the picture looks too confusing or cluttered. On this next problem, we're given a 30-60 right triangle, and we're given that the long side, the hypotenuse, is 40. And so we're going to use our template a, 2a, and a squared root of 3, and I'm going to start by writing 2a next to my 40. If 2a is 40, then I can say a is 20. And then to find a squared root of 3, I just take the value I found for a, which I divided 40 by 2, and substitute that in, and I get 20 square root of 3. This is a 45, 45, 90 triangle, so we'll use a different template. In this template, both of the short sides are identical because it's an isosceles triangle, and the long side is x squared root of 2. You could find this using the Pythagorean theorem, but we're going to assume for this purpose that you've already done that, and so you're ready to use this triangle. So to use this triangle, I'm just going to take a look at the number they give us and set it equal to the picture. So this one says 3 is x square root of 2. That means to find the other sides, I need to solve for x. And when I divide by square root of 2 on both sides, I get x is 3 over square root of 2. Now that is the answer, but it's not in proper form, because square roots in the denominator are not considered good manners. So in order to get the square root out of the denominator, we just have to multiply by square root of 2 over square root of 2. So our final answer is 3 square root of 2 over 2, because the square roots on the bottom cancel and they just become 2. When you have two identical square roots, they cancel and just become that whole number. So x is 3 square root of 2 over 2, and y is 3 square root of 2 over 2. This triangle looks confusing because on the side it has a 2 square root of 2, and on a different side on the template it has an x square root of 2. That's not as hard as it looks. It just means you're going to be multiplying or dividing by square root of 2 in your future. So let's see how you'd set it up. I've drawn my template, my special right triangle, and now I'm going to write the dimensions over next to the triangle I'm given. If it's confusing looking at it on the picture, you can draw it separately in a little chart. So if x is 2 square root of 2, then we can solve that by plugging it in. So if x is 2 square root of 2, then we're going to plug in 2 square root of 2 for the long side, and then we'll multiply it by square root of 2. So plugging in a square root to part of the picture that has a square root in its formula just means we're multiplying square roots. And that number cancels when you have a square root of 2 times the square root of 2. It just becomes 2. So it's 2 times 2, which equals 4. In this triangle, we're going to encounter simplifying square roots again. So we draw our reference triangle, and we choose that 4 equals a squared root of 2, and we need to solve for a. So we divide by square root of 2, and we end up with a square root in our denominator. In order to solve this problem, we're going to multiply by square root of 2 over square root of 2. The square roots on the bottom cancel. Now we can reduce using a calculator or by hand because 4 over 2 is just 2. And so we get 2 square root of 2. If you're not confident in your ability to reduce fractions by hand, you can put the portion of the problem that's not a square root into your graphing calculator and you can press math, enter, enter. There's another backdoor way to do these problems involving sine, cosine, and tangent that I'm going to tell you about in the next video.